Hello, dear students. Let's see the membership functions. Membership value or a degree of membership quantifies the grade of membership of the element X to the fuzzy set A. We have already discussed that earlier is that suppose if this is X, this is a inverse of discourse X, and if this is a fuzzy set A, if I denote this one as A, all the element x1, x2, x3, x4, xn, all these elements will have some unique values. That means every element will be represented in terms of its value. So based on that concept, let's see the subsequent membership functions. Now, representation of a crisp and a fuzzy subset. If you try to see over here also, you will find that the X is being represented as a inverse of discourse. This is a one element under the fuzzy set X, such that we will be getting if suppose if we draw a line like this, if we draw a straight line like this, we will get one crisp set value like this. Now here if you try to recall, we represent in this way that mu a of x, mu a of x, if you put it like this one, mu a of x, it is equal to 1 if x is within this value, and if it will be 0 if x is beyond these values. Now if you look across the other parameters, now here you will be finding that there is a sharp transitions of 1 to 0, but in the case of a fuzziness you will be finding that the transitions in this case is going somehow like this one. That means from here to here it is a linear, after that this one flats and then it is falling. So here X will be having a for every value of X you will be having a membership values. So that is what exactly in terms of a crisp set as well as fuzzy subset it means. Typical function that can be used to represent a fuzzy sets are sigmoidal, Gaussians, pi, and like that different membership representation is there that you can see in the in the later part. However, this function increases the time of computations. That means if you go from a simple linear function to nonlinear functions, the computational time will increase. This one will increase. Therefore, in practice, most of the application use linear fit functions, that you should remember. Now, coming to the other point of a discussion is that if, like a tall man. Here, up to 180 centimeter, we say that it is a tall man. If it is beyond 180 centimeter, we say that the height is no, beyond 180 is tall man, and less than 180 is not a tall man. It's an average height or a medium height. That's what. But exactly at 180, instead of considering, we can take a consideration like let's take a range of 170 to 190. No, 170 onwards. So that means there is a gradual increase will be there. So that's why in the fuzzy we don't do this is a military form of rules. Here is a civilian rules, where here military is a very stringent rules of a crisp life. In a civilian there is a gradual relaxation is there. That's why it's easy going. That's how we can take as another examples. Membership functions here with respect to the temperature of freezing, cool, warm and hot. Freezing here if we take a consideration 10 to 50 range of a freezing, if you consider. Freezing also has a part of a cool, so we can take 30 to 70 is a cool range, and 50 to 90 is a warm range, and beyond 70 is a hot range. So that means if somebody says a membership function like this, let me take a example with respect to a membership functions that are at this representing like this. If this is being represented like this, So we can say that and if we take these two things, we will say that at this particular interval there is two different values. So this will be having a coolness, this will be having a freezing point. At this particular point it is having a coolness, this particular point it is a freezing. I think my figure I can put it in a reverse way, that suppose a condition goes like this one, then I will say that somewhere if it is falling somewhere on this side, this one is a freezing point. What I mean to say is that the freezing point, cooling point, warm and hot, it's depend upon the condition that you prefer. Suppose if I am taking a line like this one, at this particular interval, what are the warms, what are the cool point, that is being given. So here at this particular temperature, the coolness, warmness is this one, the coolness is this one. But at this particular point, if you take it, the cool is maximum, that is 1. But beyond this one, the coolness value, the membership function is less than 1. Similarly, there is a freezing point as an example. They are drawn one thing. So at this particular point, you will be finding that the two different value, 0.7, 0.3, that is a freezing point. How do you use a fuzzy membership functions in a predictor logic? So that is being used based on the two condition, conjunction and disjunction. This is a minimum is nothing but AND operations. This is a disjunction is a OR operations. Let's take a fuzzy set A and B like representations. So here A and B is represented like this one. If I take a conjunctions of the A and B, so among these two value, the minimum value we should select it, which is termed as a degree or a quality C of the conjunction. So A conjunction B is nothing but C, which is the quality C is 0.375. Similarly, disjunctions case is that we will take a maximum of this value, that is A conjunction B is the C is equal to 0.75. Rules are being used in the fuzzy. If it is sunny and a warm, dry fast. So sunny and, since it is denoted as and, so that's why we termed this particular we used this particular terms here also for the and. If it is a cloudy and cool, drive slow. Or if you can put it this one, that if Rahul is smart and energetic, he can play football. If Rahul is studious or hardworking, he can take a break. So like that type of a statement, you can able to use it for the rules. Now, type of a membership function. There are different types of a membership: S-shaped, Z-shaped, triangular, trapezoidal, Gaussian distribution, pi, vicinity. Now, S-shaped membership functions is being represented in this particular forms, where you can try to see this one. At if it is a beyond beyond A, this is the A which is being represented, A, B and C. If it is less than A, 0. If it is between A and B, this is the equation, slope equation is there, because this is a slope equations. So you have to create a slope equation, that is x minus A divided by C minus A. So that is the slope equation you have taken for A less than x. If it is a B less than C, then it is a 1 minus 2 in bracket of x minus C by C by N. If you can do algebraic and hypothesis form of a equation study, then you will come across this one. And if it is beyond C, it is 1. That is termed as a S-shaped membership functions. Now coming to the Z membership functions, it is a reverse to that of a S-shaped membership function. Now you come across a triangular membership function, you go along with the similar pattern, and you will observe that here also, if it is x less than A, x is between A and B, then this particular slope equations you can take it. reverse is going if it is between B and C and 0. Similarly for trapezoidal you have the similar equations. So here 1, 2, 3, 4. 4 steps, 4 equations. Here 1, 2, 3, 4, 5. So that's why you have 1, 2, 3, 4, 5 equations. Pi, it is being represented in these forms. Sorry, Gaussian is represented in this form. Pi is represented in these forms, and the vicinity function. So every functions, depending upon its complexity, you can able to use. But you have to remember, if the complexity increases, computational times also increases. These are the two great scientists and technocrat who contributed the fuzzy into applications area. One is Ibrahim Amdani and Michael Sugino. They have used these particular examples to solve an applications like linguistic variables, linguistic value, membership functions, like that. These three things they have taken. Now membership functions, linguistic values, and linguistic variable is being used to solve the equations. The linguistic variable is temperature, linguistic value is a fuzzy set cold, warm, and good, and membership functions. In place of a cold, you can however it is called, so this will go in terms of a value between 0 and 1. Here also between 0 and 1, and we here also between 0 and 1, and you can able to solve it. Membership functions, connectivity, disjunction, and the conjunctions, it is being shown. If you are using the if and then rules, and then you can write this particular fuzzy disjunction conjunctions function, and thereby you will be able to get a different membership functions. Now the traditional representation of a logic in terms of a crisp by writing a program is that if the speed is less than is equal to 0, the snail will go in a slow speed, else it will go fast, just like a leopard. So this will become speed is equivalent to 1. For every problem we must represent a fuzzy set. Fuzzy set is represented in terms of a two range values, whereas this is having a fixed one values. So if it is the slowest, slow, fast, and fastest, we should put the range. That is how the fuzzy is being represented. Now here also in the algorithms programs, it is written, if the range is between 0 and 0.25, speed greater than equal to and less than 0.25, automatically it will be slowest. Similarly for 0.25 to 0.5 range, slow. 0.5 to 0.75 fast. 0.75 to is fastest. So this covers the final area of the fuzzy logic representations. Thank you.